Welcome back. This is Mrs. Rubright with Advanced Geometry. Today's lesson is 2-7, Prove Angle Pair Relationships. Write a proof. Given, segment AB is perpendicular to segment BC. Segment DC is perpendicular to segment B. Hold up, let's see what this says. C. Prove angle B is congruent to angle C. So, the first thing we're going to do is we're going to write our given, and we're going to state that they are given. Then I'm going to look at my diagram and mark it up. So it says that AB is perpendicular to BC. So we're telling you this. Then they're telling you that BC is perpendicular, so they're telling you that. That's all that we know so far, right? What are we trying to prove? We're trying to prove angle B is congruent to angle C. Well, why don't we go into the fact that they're perpendicular? Isn't perpendicular a vocabulary word? And anytime we have a vocabulary word, the next thing we do is we say what we know because of the vocabulary word. And then the reason is the definition of the vocabulary word, right? So based on them being perpendicular, if they're perpendicular, then they are right angles. So angle B and angle C are right angles. Why? Definition of perpendicular lines. And then if they're right angles, they are what? Congruent. Right angles congruence theorem. So because they are right angles, we know they're congruent because we have a new theorem, the right angles congruence theorem. So that saves you the hassle of having to say angle B equals 90 degrees, angle C equals 90 degrees, definition of right angle, and then angle B equals angle C would be transitive, because if they're both equal to 90, then they're equal to each other. That would totally work too. So there's not always just one way to do the proof. A lot of times there's a couple different options you could kind of go with. Does that make sense? So you could have just went from the right angles to angle B equals 90, angle C equals 90, definition of right angle, and then set them equal to each other by transitive, because if they both equal 90, they equal each other. And then you'd have to get out of angle B equals angle C into angle B is congruent to angle C, definition of congruence. Right? So, like, you would just have that extra step. Ooh, I don't know what I just did. Okay. So, moving on. Prove that two angles supplementary to the same angle are congruent. So, our given, angle 1 and angle 2 are supplements. Angle 3 and angle 2 are supplements. That's given, right? We're trying to prove that angle 1 is congruent to angle 3. Well, if 1 and 2 are supplements, that's a vocab word. What do we know about supplements? They add to 180. So we know that angle 1 plus angle 2 equals 180. Angle 3 plus angle 2 equals 180. Definition of supplementary angles. Right? Anytime there's a vocab word, the next line is what we know because of the vocab word, and the reason is the definition of the vocab word. You guys started to see that there's a pattern to all these? Do you guys see how they're both set equal to the same thing? Transitive property. Angle 1 plus angle 2 equals angle 3 plus angle 2, right? Transitive. Subbing a whole side for a whole side. Do you guys see how they both have an angle 2? Subtract it from both sides and it'll be gone. The measure of angle 1 equals the measure of angle 3. Subtraction property of equality. What is my answer supposed to look like? It's supposed to be angle 1 is congruent to angle 3. Change it and say definition of congruence, right? Or definition of congruent angles. And that's it. So these are not as hard as they look. At first, they look very scary and challenging and confusing. But once you start getting the hang of it, you're like, okay, they're not as bad as I initially thought. You're going to get better at them. You're going to see that we're using the same types of reasons over and over again. And you'll start to discover the patterns. Prove vertical angles are congruent. So we are given that angle 5 and angle 7 are vertical angles. So they gave us angle 5 and angle 7 are vertical. And we're trying to prove that 5 and 7 are congruent. So, because they're vertical, right? Because they're vertical, they're congruent, definition of vertical angles. But we can't use definition of vertical angles to prove the definition of vertical angles, right? So you have to use something else. When you're proving it, you can't use it. Does that make sense? So you're trying to prove this without using that fact. So what we have to do is other things. So we can say that angle 5 and angle 6 are a linear pair. And we can say that angle 7 and angle 6 are a linear pair, correct? They both form straight lines. They add up to 180. So we say that they're linear pairs. Definition of linear pair is shown in the diagram. Because they're linear pairs, they're supplementary. Linear pair postulate. Right? And then we have a cheat sheet. This is a theorem that just eliminates a bunch of extra steps. Because in the past, we would have had to say, okay, well, if they're supplementary, then the measure of angle 5, like angle 5 plus angle 6 equals 180. Angle 6 plus angle 7 equals 180. Definition of supplementary. Then we would transitive it. Angle 5 plus angle 6 equals angle 6 plus angle 7. Transitive property. Then we would subtract angle 7 from both sides. Angle 5 equals angle 6, right? So we'd have like, wait, did something get messed up here? It should be 5 and 6. This is a typo. So because the 6 overlaps, you would subtract it and you'd be left with 5 and 7, right? That's how you would have done it, all those extra steps. But instead of having to do those extra 3, 4 steps, you can just go straight from the fact that they're supplementary to the fact that they're congruent using congruent supplements theorem. Congruent supplements theorem is just simply saying that if two angles are congruent, are supplementary to the same angle, then they're supplementary to each other. Does that make sense? So congruent supplements, these two angles must be equal if they're both supplementary to the same angle. So since they're both supplementary to the same angle, these two must be the same. Because an angle plus angle 6 equals 180. Well, then a different angle plus angle 6 that equals 180 must be the same. That makes sense, right? It has to be the same because they add to 180. So like if I said that angle 6 was 60 degrees, well then 5 would have to be 120. If 6 is 60 degrees, 7 would also have to be 120 because that's the only way that they're going to add up to 180. Right? So that makes sense. So you have occasionally, you're going to be learning these postulates and these theorems and these corollaries that are just going to like make things easier and they just eliminate excess steps. Is the old way okay? Yes, you could have this be like 8 steps and still be correct. But these are shortcuts. Okay, and then on the EOC, the shortcuts might be listed in multiple choice options and stuff, or drag and drops. So it's important to know them. All right. So, if the measure of angle 1 is 112 degrees, find the measure of angle 2. What's the measure of angle 2? 68, right? Got to be 78, so 980, 180. They'd add up to 180. They're a linear pair. What about 3? 112, it's vertical, guys, 112. And it's supplementary to the 68. And vertical to that 68 over here. So, if you're given one number, when two lines intersect, you should be able to find all angles. And the measure of angle 2 is 67. Find the measure of angle 1, 3, and 4. So it's 2 is 67. What else is 67? 4. 180 minus 67? 113? Which makes this one 113. Make sense? Angle 4 is 71. What's angle 1? 109. Good. 2. 71. 3. 109. Good job. Which previously proven theorem is used in example 3 as a reason? Which previously proven theorem is used in example 3 as a reason? What do you guys think? Congruent supplements theorem. Good job. Which equation can be used to find x? Which equation can be used to find x? What do we know? We know that 32 plus 3x plus 1 has to equal 180. So B. Solve for x. So we know that 32 plus 3x plus 1 has to equal 180. 32 plus 1, 33 plus 3x has to equal 180. Subtract 33 from both sides. 3x equals, make that a 10, 8 becomes a 7. 147 divide by 3. X equals, 3 times 4 would be 12. 2 more to get to 4. So that'd be, to get to 14, so 27. So that'd be 9. Right? 9 times 3 is 27. So 49. X equals 49. And then now that we know that X is 49, what is TPS? Angle TPS. Angle TPS is the same as this angle, correct? So it'd be 3 times 49 plus 1. Well, 3 times 50 is 75, right? And I'm how much short? Wait, sorry. 3 times 50 is not 75. 3 times 50 would be 150. 150 minus 3 is 147. 147 plus 1 is 148. So it should be 148 degrees. So we have 49 and 148 degrees. And that is everything on your lesson on 2-7, Proving Angle Pair Relationships. We hope you enjoyed the lesson. Have a great day. Like and subscribe.